let's take a look at these problems and see what we can get out of these problems, what we can do to answer these questions. But these questions fit into that category of three things, you get two, find the third thing. Out of two, find the third thing. Given two things, find the third thing. So the first one is going to serve as the basis for the next couple of problems. If distance is equal to rate times time, how can we rearrange this? Distance is equal to rate times time. That's one of the things that we remember. How can we rearrange this to figure out what the rate is? What is rate in terms of distance and time? So if I take the distance and put it in the 6 and think of it as the 6, and then rate and time as the 2 and the 3, I know that in the division, the 6 will have to go on top. So in the rate, distance is taking the role of the 6. That goes in the top. And in the denominator, we will put time. We can just rearrange, use the relationship between multiplication and division to rearrange and to figure out the rate. If distance is rate multiplied by time, then rate is distance divided by time. That's just the relationship between multiplication and division. Since 6 is equal to 2 times 3, 3 is 6 divided by 2. It's the relationship between multiplication and division. This is no different than looking at distance equals rate times time as an equation, and we're solving for rate. Rate is being multiplied by time, so we divide both sides by time. Distance and rate is distance divided by time. So it's not different than what you might be familiar with. What we want to avoid is memorizing three things that are all just secretly one thing. I don't want to remember that not only is 2 times 3 equal to 6, but 3 is 6 divided by 2, and 2 is 6 divided by 3. I don't want to remember three things when I can remember one of those things, and then how multiplication and division are related. Does that make sense? I don't want to remember a whole bunch of things. I want one thing and then how they're related. That way I could use the thing in more situations. If rate is distance divided by time, then time is going to be distance divided by rate. Once again, this could be solving either one of these equations for time. If I want to take this red equation, solve for time, I'll divide by rate because it's included with multiplication. If I want to solve this equation for time, I'd have to multiply by time and then divide by rate. That seems like a lot of work. But if that's what you remember, then that's what you remember. Oh. So let's use this to answer some questions. In problem number 2, we were given two pieces of information. We were told that we were given a 400 miles in 5 hours. Of distance, rate, and time, which is the 400 miles? What is that going to be called? That is a distance. It's in miles. We know miles means distance. And 5 hours, which one is that going to be called? That's a time. So I've got a distance and I've got a time. What am I going to do with these two numbers? Find the rate, and what operation am I going to perform to find the number? Find the number with the numbers. We're going to divide. What divided by what? 400 divided by 5. And what will that give us? 80. And what are 80 what? Miles per hour. Perfect. That's the units are telling us what to do as well, because per just means divided by. Miles per hour. That means miles divided by hour. It's like it's telling us what it wants us to do. So we'll take 400 miles and divide by 5 hours. That's going to be 80 miles per hour. How are we doing so far? Everybody 1 for 1 on the number parts? So you feel like, oh, I am now. it would be weird to divide it the other way. It would be weird to take the 5 and divide by 40 and get 1/80. You think that doesn't make any sense, because I've driven to Los Angeles, and it's only 55 hours, and I was going way faster than 1/80th of an hour per mile. Oh, I was doing exactly an hour per mile. But that's not the number that we're going for. We're going for the rate. Distance is equal to rate times time, so rate is distance divided by time. How much distance you cover in a certain amount of time. Rad. Number 3, how long will it take to drive 240 miles at 60 miles per hour? So I've got 240 miles. I spelled L wrong. So in the previous problem, I wanted a rate and I had a distance and I had a time. What is the 240 miles? That's also a distance because it's still miles. And 60 miles per hour, what is that? That's a rate. So I've got a distance and a rate, and I want to find a time. What am I going to do with the 240 and the 60? We'll divide. 240 divided by 60 is how much? What is it? 4. And 4 what? Hours. Here the units work out a little bit weird because it's miles divided by hours. But when so the miles per hour, I'm thinking miles over hours. Since the hours is on the bottom of a fraction, that's in the bottom of a fraction, that moves it up to the top of the fraction. So it makes sense that the miles cancel out and we just get hours. So the units, once again, tell us what's going on, because we're taking miles and dividing it by miles per hour, which is miles times hours per mile. So the units tell us what we should be doing once again. How's everybody, okay? Everybody looks so very sad. It's sad because we're driving only at 60 miles per hour for 4 hours. That seems like a lot to go that slow. Number 4, if we drive for 3 hours at 70 miles per hour, how far will we go? What are we going to do with the 3 and the 70? Multiply, and what are we going to get? 210 watts. Miles. Perfect. So I've got 3 hours. That is a time at 70 miles per hour. That is a rate. We're going to multiply. I'm going to take 3 hours and multiply by 70 miles per hour and get 210 miles. Oops. Here, the units tell us what's going on once again, because I take hours and multiply by miles divided by hours. The hours cancel out. I just get miles. How's everybody okay? Isn't trig easy? So the other number 5, we've got this generic problem. I've said that A is equal to B divided by C, and I want you to write down what is B and what is C. So if A is B divided by C, what is B equal to? Now B is being divided by C, so how do I undo divided by C? We'll multiply both sides by C, so B is equal to A times C. And what is C equal to? That's going to be a division one because we had one multiplication, we used it. What's the other division that we're going to come up with? B over A. I wrote these in fancy single line syntax. We have to be able to do division in single line syntax so we can text the answers to our friends while we're in class during the test. I don't know how your phone does super quick, but mine doesn't, so I have to use single line syntax. It means using a lot of parentheses, starting fights on the internet. It's a big thing. We're just trying to rearrange what's going on. If A is B divided by C, that means B is A times C, and that means C is B divided by A. We're just exploiting the relationship between multiplication and division. How's everybody okay? This is usually people's least favorite one. Number one, because I start with division and I write it single line syntax. Number two, it doesn't mean anything. It's just A, B, and C, some generic relationship. And for whatever reason, we regard this relationship as being more generic than than 3 is equal to 6 divided by 2. But all we did was rearrange 3 equals 6 divided by 2 into 3 times 2 is 6, and 2 is 6 divided by 3. Next, we have a little bit of a variation. I've got a new car, $1,700, and the tax on that car is $504. I question, what is the tax rate? How are we going to express a tax rate? This problem is making a lot of assumptions. First of all, that we're adults and that we know that there's this thing called tax. How do we normally express taxes? As a percentage, as a ratio. Rate, we're going to make a percentage, it means we're going to divide. What are we going to divide by what? Let's try that. We figure we're going to divide, right? So let me get a calculator. So if we do 7,200 divided by 504, does it look like the tax rate is 14.28? What would this look like as a percent? Is the tax rate 1,428%? Or did we do something? Are we on? What mistake did we make? In this case, we put the whole thing on top of the parts. The tax rate could be some part of the whole. So I'm thinking of the 7,200 as the whole thing, and the tax rate should be part of that. So one of the what this question comes down to is we're saying 504 is what percent of 7,200? We're asking a question about a percent, and we know that the 504 is going to be some percentage of the 7,200. Just occurred to me that in some places the tax on the car may be more expensive than the car itself, in an effort to discourage people from driving cars. But that's not going to be the most common experience here, so we can ignore that. So the question is about 500 is what percent of 7,200, and this sets up a multiplication. The way we want to read this is that the word is means equals, and the word of means multiply. We're going to read is as equals. Of is going to be multiply. So 504 is some percent of 7,200. So if 504 is that percent times 100 times 7,200, how do we figure out what the percent is? Doing the same thing that we did up here. I'm looking at B is equal to A times C. If I want to know A is B divided by C. So the percent is 504 divided by the 7,200. So we got 0.07. And what is this written as a percent? 7%. The second part of this problem says at the same tax rate, now the value of the car is $8,000. $8,000. So now we're asking a different question. Now, if the tax rate is 7%, and I have a new car with a value of $8,000, now the question is, I want to know what the tax is. So I say, what is 7% of $8,000? Translating this into an equation the same way, where is means equals and of means multiply. I'll say what equals 7%. How do I write 7%? Now we need to go back to the number we get the calculator on from the calculator. 7% means 7 per 100. 7 over 100 is 0.07. Of means multiply. Extend my equation because I don't have to rearrange anything. Seven times 8 is 56. 2 zeros back, 3 zeros forward, 1 0 net. People just thinking about a world in which a new car costs $8,000. Everybody okay? Are you sure? Because there was a time where new cars cost $8,000. And houses cost like $70,000. All right, let's take a pause, come back and do this 2 out of 3 business, but mix in some trig functions. We're gonna do some problems involving some trigonometric functions. So let's take a break.